Thank you everyone for coming and welcome to Building Lightning Components Securely. We are going to talk about some best practices. Now is the time to go if you're not at the right talk. But if you are, welcome to Trailhead DX. And my name is Betsy Thomas. Let's go over some forward-looking statements and get over this slide. So if you go over the slide, it says that Salesforce is a publicly traded company, so don't make any purchasing decisions based on what you hear today. Make purchasing decisions only based on what is publicly available. And with that, let's get started. So as I said, my name is Betsy Thomas, and I work on the product security team. And what I do there is work on the internal and external applications and look at the security posture of these applications, work on some tooling and automation. And a lot of you may be familiar with App Exchange. And what we do on the product security team is review applications that come through the App Exchange. And with that, I would like my co-presenter to introduce himself.
Hi, everyone. I'm Nishal. I also work alongside Betsy on the product security team at Salesforce. Also work on security review process for the App Exchange and work with our internal Einstein teams, making sure we're delivering a secure platform to all of you. So with that being said, I think Betsy's going to start us off.
OK. So let's go over the agenda for today. What we're going to talk about today is basically what Lightning is, Lightning components, what's the difference between Visualforce and Lightning. We'll just introduce these concepts for people who are not familiar, and then dive into what are the security considerations and look over all the, do a deep dive into all the security issues that we see with respect to Lightning on the Salesforce platform. OK, so what is Lightning? Next slide. So Lightning can mean different things for different people. It can be the amazing Salesforce UI, which is new. So it can be the visual building tools or like the drag and drop tools that you're familiar with, Classic as well. It can be the Lightning design system, which is nothing but a bundle of HTML, CSS, and JavaScript, which is given to you as programmers to develop on. So it gives you a good, nice UI. But what we are going to focus on is the Lightning Components framework, which is nothing but the Aura, Aura framework, which Salesforce has modified. And this helps us create reusable components which can be used throughout our applications. So with that, let's do a deep dive. So what exactly are these components? Components are basically, you can think of them as bundles of code, and they can be reused anywhere in the application. So if you look at this image over here, this is an old Salesforce, a sales application UI. And every red box over there represents a component. And as you can see, components can be reused throughout the application. They can also be nested. So we have quarterly performance, we have upcoming events, we have top deals on the bottom. And if you see, top deals has several other components within it also. So that's components. And what we would be primarily focusing on is the security behind these components. And Nishal will go into security considerations once I'm done with comparing Visualforce and Lightning. So Visualforce and Lightning. Let's compare the life cycle of Visualforce and Lightning. So what happens when the user requests a page? So in Visualforce, user requests a page. Lightning, user requests an app or a component. Visualforce, the server looks at the user's request, generates an HTML, sends it back to the browser. Lightning, the server creates an app bundle, and what the app bundle has is a bunch of HTML code, JavaScript code, and CSS, sends it back to the server. The next thing the browser does in Visualforce is it displays the HTML, but in Lightning, the difference is that the JavaScript, which is bundled back and sent, it actually displays the UI. So it may display a part of the component, as we saw before, And so the next step is the user interaction. So when the user interacts with the UI in Visualforce, supposing the user enters in some form information, sends it back to the server, the whole request goes back to the server, and then the server does the whole process again of sending the user all the information again. However, in Lightning, the JavaScript is what does this interaction, and only parts of the pages where the user interacts with are changed. So this gives a more single-page application feel to the for the user experience. So with that, let's go into what are the security considerations that you have to think about with respect to Lightning.
All right, thank you, Betsy, for that introduction to Visualforce and Lightning. So for those of you that are new to Lightning, hopefully you've seen some of the differences between Visualforce and Lightning at a high level. What I want to get into here is some broader themes that will guide the rest of our talk, and just things to think about as you're developing Lightning components or applications. So we just saw this slide, this image from when Betsy was talking about components, but what I want to focus is on what does this mean from an attacker's perspective. If I'm an attacker and I want to attack a Lightning application, what do I see here is the first thing? Well, I see a bunch of these components. These components are all nested, et cetera. But as an HTML page, as a web application developer, what's important here is they all share the same DOM. And so how do we secure components from each other? So for example, your component that you're writing, perhaps that's getting put onto the App Exchange, could be mixed with a component that is developed by your customers internally, or with another App Exchange package, another managed package. And so you, as a developer, have, there's no real way to understand or guess where your component is going to be placed on this page. It could be anywhere. It could be instantiated by another component, perhaps. So there's very little control that you have on the entire DOM. And so we'll get into like how do we protect components from each other, especially when maybe my component has a secret I don't want to share with other components. So the first thing, and this is a general principle from web application security, is always consider the user as a potential attacker, right? This could be business logic bugs, maybe even CRUD or FLS for some of you that have done plenty of Apex programming. So, you know, so like, for example, maybe you have a page that allows you to see certain data in a Lightning application, and you have another Lightning application that reveals more information because it's not enforcing the same access control permissions. And so you always have to think about what information am I revealing that an attacker could just click around and they would get. The second one is to think about the client being an attacker, and this is something of contention sometimes with developers, is that remember that an attacker can always intercept a payload from the browser. So they don't need to know how your application, your Lightning application works. They generate the request, let the browser intercept it before the browser sends it over the network or over the wire, and they take that payload and insert whatever data they want into it, right? This is where server-side validation is extremely important for web application security. Anytime you have maybe an Aura-enabled method on your Apex controller, you always want to validate what's coming in because you never know if that data has been manipulated. And that just goes for general web applications, and it's still true for the Lightning framework. The third one, which I hinted at earlier, is new because of how the Lightning framework works, and it's that the other component could be an attacker, especially when you have components that are instantiating your component. And we'll see some of the issues that come up with that, such as potentially like XSS through trusting global attributes. So with that in mind, I want to pass it back to Betsy to go over improper access control, and we'll get right into it.
Thank you, Nishal. So improper access control. When we talk about access control in a Salesforce application, we're primarily talking about three big things when it comes to development. Next slide. So the three things here are CRUD, FLS, and sharing. So for those of you who don't know, CRUD stands for Create, Read, Update, and Delete. FLS stands for Field Level Security, and sharing talks about record level security. So let's look at a high-level view of what all these three things are. So for example, if you look at it this year, if you think of your entire Salesforce application as a spreadsheet, say. So on the bottom are different tabs: contacts, accounts, opportunities. These are objects in your Salesforce org, and access to these objects is defined by CRUD. Now, if you look at the columns ABC, you'll see first name, last name, title, street, etc. These are fields inside each of your objects. So these are fields in particular in the contact object. And access to these fields is defined by field level security. And then if you see on the left, you see sharing, which defines access to each and every record or each and every row over here. So if you want to define access, if you want to say that a certain user should get access to row 5, 6, and 7, that should be defined by sharing rules in your org. So how do we enforce that in the code? So first of all, what is the problem here? The problem is that Apex code, because we want developers to have flexibility of writing this code, we give Apex code system context. So it runs in system context. And so an Apex code does not know whether this user, a user A, has access to this particular record or not. It does not know whether user A should have access to a certain object or a certain field in an object. So these are things which a developer needs to define. And here is how you do it. So if you look at the code over here, sharing rules, if you see the first line over there, the sharing rules are defined with which sharing keyword in the class definition. CRUD rules are set in line 3. So if you see, line 3 defines if the user has read-level access to accounts object. Line 4 defines if the user has read-level access to the balance field in the accounts object. So that's how you do it. So let's look at an example to really understand this, to understand what is the issue and how to fix it. Full screen. Okay, awesome. So this is an org. We are logged in as a test user. And if you see, the test user has access to certain objects. Opportunities is one of the objects. And if you see, the user has access to one opportunity. If you look at the opportunity you can see like a bunch of fields, but one field that the user does not have access to is tracking number. So you can see on the top right, I'm searching for tracking number and I don't have access to it. So we have established that this particular user does not. So I've created an application which displays the opportunities of the user. So this is supposed to be that application, but if you see this user, in my application, because I'm not checking for CRUD, FLS, and sharing, this user has access to too many opportunities and also has access to the tracking number field. So the user should not have access to this. So let's look at the code. This is the component that I built, which we just saw. And this uses the underlying zip4 controller. So let's go and see what that does. Get opportunity. And let's look at the controller now. And if you see, this is the code for get opportunity. If you see, the first line itself does not have sharing enforced. I'm going to change that and put in with sharing. And then line 8 seems to be just fetching all the opportunities. So I'm going to comment that out, and I'm going to actually put in CRUD and FLS rules. So if you look at line 12 over there, you will see that I am checking for CRUD. So if the user has access to the opportunity object. If you see line 15, I'm checking if the user has access to tracking number. And if the user does not have access, I'm going to display access denied in the tracking number field. So let's go back to our application and refresh this page. And in 1 second, we will see that now the sharing rules are enforced and user has access to only one opportunity, which they are supposed to, and tracking number has access denied. With that, I'm going to pass it on to Nishal to talk about XSS issues.
Awesome. Thank you, Bessie, for that great explanation on CRUD FLS. I'm going to go into more Lightning-specific topics. So cross-site scripting, OWASP top 10 issue, very familiar to the web application security community and to a lot of web developers. So a lot of questions we get, doesn't the Lightning framework protect against cross-site scripting? And yes, that's true for most cases. And there are ways you can introduce cross-site scripting as a developer into your application that we want to go over, and what are called anti-patterns. So we want to go over these anti-patterns and explain why they can get introduced into the app and why the Lightning framework is unable to help you in certain cases. So here are two examples. We're going to assume we have a variable called foo in our component, and this foo could be is manipulated by user input. So just direct input from the user, and that's what foo is set to. And what if we set foo directly into an href tag? That could be perfectly reasonable. Maybe I want to send the user, they click on this to salesforce.com. It's a perfectly legitimate use case. What the issue is what if we have JavaScript colon, right? In an href tag or href value, you can set JavaScript colon and you get a script context. So this can actually introduce cross-site scripting. And why is that the case? Why isn't Lightning helping us here? And the issue becomes JavaScript colon with a bunch of text after it could be a legitimate string, right? What if I have a knowledge base article explaining how JavaScript works? That's a perfectly legitimate string. But in the case that we're putting that value in the href as an href value, Lightning has no idea what that context is. It's not aware. So as a developer, you have to ensure that whatever is going into an href, or on the below you have the iframe source tag, whatever you're putting in there is actually sanitized. And we'll go into what does a good sanitization function for these use cases look like. So in most cases, if you have security people on your team, or whether you're looking around, regexes are generally a bad idea for security application purposes. But this is one of the few places it does work. And we're simply just going to check if the protocol is HTTPS or HTTP. Right? That ensures that you don't have a JavaScript or a data context to execute scripts. So this will help with some of those cross-site scripting issues. The other protection you can enable, if your users are on modern browsers, Safari, Opera, Firefox, Chrome, and Edge, is that they provide what's called content security policy, also known as CSP. We won't get into it too much. Mozilla Development Network has great resources on it, but it's something that you can enable in your Salesforce org, and something that is a policy provided by, it's a browser directive. And basically what it'll say is that, hey, we don't want JavaScript running, we don't want user JavaScript running in the page, essentially. And so we're going to talk about, yes. So the next topic is untrusted global attributes, and this is very related to cross-site scripting and one of those very Lightning-specific issues. And what do I mean by untrusted global attributes? Well, we have more code. So we have a component. Its access is global. That's important because that means that any component can initialize my component that I'm writing here. It has a global attribute. So that means that whatever component is initializing my component can also instantiate this attribute with a string of whatever the component wants. And it's set to the variable var. And so what is the issue? We have iframe source equals v.var again. That's very similar to the issue we just saw with introducing cross-site scripting, maybe as a user input. Here, it's almost the exact same case. We have potentially some other user, in this case a component, initializing this iframe source tag, and it actually can introduce a cross-site scripting payload into here. You can also do it with Aura unescaped HTML, which assumes that the var is unescaped. And these are things that we have seen on the App Exchange when they are going through security review. So these are issues we do see pretty often. And so you want to treat all global attributes as potential attacker-controlled input, right? You don't know who's instantiating your component. You don't know if that component is malicious. You know nothing about that other component. And also to remember that global components can be inside any other component. So same situation there. So I want to tie this all together and with a quick demo. So here, we're just going to have, that's a bit hard to read.
Do you want
so
this?
I will No, it's highlighting. So we have a component acts as global for those of you that can't read in the back. An Aura that's also global. Its name is called global var. And we're running an API version 40 as an application, and we're inputting it into an unescaped HTML tag. And what we have here is we're just going to display also the string that we're inputting just for readability's sake. Nothing special about it. It's really that Aura unescaped HTML that we're looking at. This is the application, and it's initializing the component with a string, hi there. Hi there is initialized. There's nothing wrong with the string hi there, or hello world, or what have you, right? But it's going into that unescaped HTML tag. So what can we do? So if we go back to another application, my evil app, we can initialize it with this long string, and essentially what it's going to do is show our favorite characters, Einstein, Cody, and Astro, to appear on the page with that, right? We've actually manipulated the DOM and inserted that image tags. This is a very non-malicious use case, but we have script execution here. And this is something CSP could protect against if you have it enabled. But in this org, it does not. And so that's just the payload that's running. So you always want to make sure that XSS can be introduced into Lightning components. There are certain ways, and this was just a way to highlight those issues. Awesome. I'm going to pass it back to Betsy to talk about cross-site request forgery.
Okay, so cross-site request forgery, and a lot of you might have heard about this, was one of the OWASP top 10 issues, and can be introduced in a Lightning application, and there is one and only one way to do that. So let's take a step back and let's talk about what cross-site request forgery is. So cross-site request forgery is when an attacker gets a user to click a link or go to their evil website and probably click somewhere and send a request on the user's behalf. The assumption here is the user has your application open, so in this case Salesforce open, on another tab, and a request gets sent and the server has no idea whether this request originated from Salesforce or did it originate from the attacker's domain. So we will go into an example of this, but first let's talk about what the issue is with respect to a component. So if you look at the example here, you'll see a component definition over here. What we're doing is when the page loads, we are doing something called doInit. And let's see what doInit does. So if you look at the example over here, all doInit is doing is fetching create account, and create account lets assume that you have defined this in Apex, and it's just creating an account. So every time the user navigates to this page, a new account gets created. And this is the problem. The only way you can introduce CSRF or cross-site request forgery in Lightning is to have it in your page load. And once this is done, what we suggest is not putting any kind of state-changing activities in your page load. So let's look at an example. So we'll go to the same user that we used for our CRUD FLS demos.
Lost my mouse.
Lost your mouse. Just press space.
No, sorry.
Some technical difficulties here. Okay, so we'll look at the same test user. This user seemed to be having, let's look at what opportunities this user has, and this user still has access to opportunity 3. We have slightly modified the underlying code of our application now. So if you look at this, if you see Aura handler, it says doInit. And so let's go and see what doInit does. And in this example, doInit, what it does is cause something called delete account. Let's go and see the underlying Aura code, Apex code. And if you see, I'm checking for CRUD. And in the example here, I'm deleting all opportunities on page load. And let's see if this actually works. So as an attacker, all I do is send the user a link. And when the user clicks the link, so that's the link, I hit enter, and looks like I get an empty page. Let's see if all the opportunities have gotten deleted. So I'm going to refresh this page, and if you look at the result here, all opportunities are deleted. This is a classic example of CSRF, and the best way to prevent this is to have some sort of click or some sort of action for the user to do. So you say, if you want to delete these users, these opportunities, click delete. And that way the user knows what's happening. Let's look at another issue that we usually see, open redirect. And this is an issue usually if you want to introduce a redirect to another website for the user based on what the user input was. So let's say, if you look at this example, I've defined a component here as well. And if you look at this example, there is an attribute named redirect URL. And on click of a button, I'm getting redirected. So what happens in the underlying JavaScript code is that I'm changing my URL to whatever the user inputted. And so with this, what will happen is a user clicks a link. If an attacker is able to modify this user input value, redirect URL, which is completely possible, then the user will be redirected to any domain that the attacker controls. And if a user is redirected from Salesforce, then the user is going to trust that domain because they're going to be redirected from Salesforce, so it's safe, right? It's not. So the best way to prevent this is something called as whitelisting. So what you need to do is at least check the domain and the schema. So as Nishal had pointed out, check HTTPS, yourdomain.com. If that is right, then you can go ahead and redirect the user to whatever URL it is. With that, I'm going to pass it back to Nishal to talk about locker service.
Awesome. Thank you, Betsy. That was a great explanation on Open Redirect and CSRF. I want to talk about locker service now, and this has been a point of contention with a lot of our Lightning developers, and some of you may see this as an issue yourself. But I want to get into what is locker service, and especially what locker service is not, and it's been a lot of confusion. So locker service, one of the primary things it does is it wraps standard JavaScript objects that, as a web application developer, you expect to be there. Window becomes secure window. Document becomes secure document. Locker service is actually open source, and you can actually see the feature parity between your standard JavaScript objects and the locker service version of those. And that's online, and we can point you to that after the talk. And you can also see what locker service does to change things under the hood, but we don't want to delve into the details there too much. The second is that it restricts DOM access within the same namespace. So if you're developing a package for the App Exchange, for example, and you have your own namespace, let's just call it example. In this example namespace, any component can go and reach into the DOM of that other component. What locker service will prevent is it'll prevent me from reaching into the DOM of perhaps another namespace. So if I have example and example 2 developed by 2 different App Exchange partners, or you have 2 different namespaces, locker service will say that access is not allowed. And so the issue becomes, well, how do components talk to each other? How do they communicate? And we'll get into that in a second. But that is what it does. It's within the same namespace. And it's only enabled in API versions 40 and higher, and we're actually going to demo why this is really, really important to understand. And it's on a component level, not on the application level. So if you're developing a Lightning application with API version 40, locker service doesn't care. There's no relation. What it does care about is the component and what API version the component is. What locker service helps protect is against more subtle XSS attacks, such as like the components attacks that we've seen, and some more exotic attacks. The other thing it does provide is additional protection over CSP. And so why is this? Well, CSP is a browser directive, and it has no understanding of the Lightning framework, right? If you're React or some other developer, or for another framework, right? Your browser doesn't care what that framework is. It's ultimately just JavaScript at the end of the day, and that's what it's running. So CSP is a browser directive. It has no understanding of what the Lightning framework is or isn't. It doesn't understand components. It doesn't understand any of that. So locker service is additional protection over CSP because it's isolation between components, something the browser can't do itself. And the other point to keep in mind is, hey, I want to run jQuery with locker service or some other open source JavaScript library that you may have downloaded for your Lightning application. Well, how do I know if this is compatible with locker service? The easiest answer I can give is that the third-party library has to be built with ECMAScript 5 strict mode. If it's not built with this, we can't provide really any guarantees or any hope with why it doesn't work. And this is just something, this is how locker service was built, and unfortunately, if it's not built with that library, it's not going to be built with that mode. It's not going to work with locker service, most likely. So I want to get into this. What is locker service actually doing? So we have an Aura application, API version 40, and that's just to demonstrate the API version does not matter for the application level. We're going to have an unmanaged component, which is in the C namespace, for those of you familiar with just development. And then it's going to be called my component. My component is going to run API version 41. So this is higher than 40. It has locker service enabled. It's in the C namespace. And ID equals ID. Oh, okay, 41, just showing that. And then ID equals ID. So this is an important point to keep over as I show the next component. We're going to have a name collision here. And we're just showing breaks, just readability. And we have a managed component from a managed package we may have downloaded. It's called df17sec, that is the namespace, and it's called locker protection. This component, it has a global access, so we can initialize it. It's running in a managed package namespace, and that is the namespace df17sec. This is just tagged to readability as we get to the application, so you'll be able to read it. And it's running 38, so locker service is not enabled here, right? So we have one application, one component running locker service, the other one is not. And it has ID equals ID, right? So there's a name collision between the ID. And so what are these components doing as part of this demo? It's running on a button, press count higher, and all that is doing is just counting 1, 2, 3, 4. It's just appending other list elements to it, nothing complicated. And this is showing the JavaScript, so it's getting the element by ID. So there's a name collision. It's creating the list element, setting the inner text to 1 higher, so we're getting the counting function. And it's appending the child back in, and then we're setting the counter value back in the Lightning component. And then we have some fancy UI color changes just to see what's going on. So so this is application version 40, right? Namespace is C. This is the 41 PI, and it's running this one's running in a different namespace, version 38, and we hit count higher. So, can you go to that last second there? Keep going, keep going. Stop it. Okay. So what happened here, right? We had count higher. That was supposed to count higher within my own component. Why is it manipulating the DOM of another component? That doesn't make sense. So the way locker service is deployed in Lightning is that it only ensures that your component is a good citizen. It doesn't prevent other components from being a bad citizen. So here we had a component running version 38. It did not have locker service enabled. So there was nothing telling this component it couldn't reach out of its own namespace. And so it was actually able to manipulate a component that had locker service enabled, because locker service protects what's going out, not what's coming in, in the way that it's deployed. So we're going to show what happens when I bump up the version of that component from 38 to something with locker service enabled, and what does a locker service error look like. So this is part 2. Awesome. So this is the exact same. Nothing has changed here in this code. We still have our unmanaged component, and we have our Aura application running version 40, and we're going to see that this is still at 41. Nothing has changed here with this component. It's the exact same code. And then we're going to go back to this component that's been problematic. and we're going to go and we're going to change it to 40. Right? And I've tagged it there. That doesn't change it, but I'm just going to show you that it did get changed there. And we're going to see the preview, and we're going to hit the button, and we get an error message. And this is Locker Service saying, hey, you're accessing a namespace you shouldn't be touching, the DOM you shouldn't be touching. And that's the way Locker Service currently works. And so the analogy that I like to stress is Locker Service ensures you're being a good citizen, doesn't prevent others from necessarily being a bad citizen. So if you're an admin or you're using Salesforce, you want to ensure that any components you're developing that are on the same application all have Locker Service enabled, and that's how you get the full protection for it. What I want to get into, I alluded to this earlier, is, well, how do I talk to components and other namespaces? What is a solution for that? I can't manipulate the DOM for these components. Well, we have something called Aura events. So quick side note, Aura is the open source framework that Lightning is based on. So this is provided by the Aura framework itself. So Aura events are a publisher-subscriber model. So what does this mean in the Lightning world? So that means as a component, I publish an event, and the Aura framework handles it. I don't care if any components listen to that event. I don't care if 1,000 components listen to that event, right? And same thing as a receiver. I don't care why an event happened. I just have to know it happened. And so with that being, that's sort of the publisher-subscriber model, right? So this gives you a lot of scalability, right? I alluded to this. You don't care if 0 or 100 or 1,000 components are listening to this event. It gives you a lot of reusability because it takes away a lot of interdependencies that you could have by managing the state of the DOM yourself. So you get good reusability that way, and security in the sense that, hey, we have Locker Service enabled. We're using Aura events to handle this. And so it's very hard to break this. And event handlers stay in the Aura framework. So if you are using a JavaScript component, essentially, not a Lightning component, it'd be very hard for these events to propagate outside of the Aura framework. So these have to stay within Aura or within Lightning. That's just the quick side note. So with that being said, I know we talked about a lot of things, so I want to take a quick recap of all of the big points that we've made. Sanitize user input and global attributes, right? That's something special to the Lightning framework. Locker Service ensures your component is a good citizen, does not necessarily prevent others from being bad. Locker Service is only enabled in API version 40. Use Aura events for communication. And then properly enforce access control at all times. This has been the big theme over the years, whether you're doing Visualforce or Lightning, because it's still server-side. No CRUD operation, so mostly the read is okay, but create, update, and delete on a page load, so those init functions don't do that. And any redirection that you're asking the user to do to whitelist those sites. So quick note, these are the other security talks here at TrailheadX. We also inserted one about Locker Service. The architect of Locker Service, the guy who came up with this whole idea and how it works. If you're more interested in getting into the technical details, he'll be talking there. That's the second talk there at 3 o'clock. The first one listed is actually this one. So, and then definitely recommend going out to those. So thank you all for your time. We appreciate it. We went over a lot. If you have questions, we're here to answer them. We have about a minute and a half. We're also in the security booth in the...
right next to the Waterfall Theater.
Next to the Waterfall Theater. So you can also find us there if you have questions and you can't stick around.
Nice.